Hello, my name is Marley Yareni Montoya Ordóñez. I am industrial engineering student. Today I am going to explain exercise number 1, integer programming model, letter A. First, I will be free explain the problem situation. The company producing three types of bad soap, type 1, type 2, type 3. Um, each type of soap has a different production cost and requires different quantities of raw materials such as vegetable fats, essential oil, and sodium hydroxide. Um, the objective of the company is to determine how many units of each type of soap should be produced using the available resources to minimize the total production cost. And we define the decision variable as x1 number of units of type 1 sub x2 number of units of type 2 sub x3 number of units of type 3 subs. So the objective function is 9400 x1 plus 8500 x2 plus 7600 x3. What we do is use the dual simplex method, and we know that we have the result when the solution is no longer negative. Is no longer negative. After formulating the model, the problem was solved using the dual simplex method and verified with solver. According to the linear programming solution, the optimal plan is producing produce 140 to paint 857 units of type 1 soap, produces 0 units of type 2 soap, produces 742.857 units of type 3 soaps, and with a minimum cost of 6,988,571 dollars. And finally, I can conclude that the integral programming model allows the company to make real production decision, minimize costs, and using resources efficiently. Thank you very much for your attention.
Hi everyone, I'm Michael Martinez Marin, an industrial engineering student. Today for deterministic methods, I explain the Vogel's approximation method. It is a very efficient tool for transportation models. We have a full company with 5 warehouses and 6 destinations. Before starting, we must balance the models, ensuring total supply rows equals total demand columns. Vogel approximation method. We balance rows and columns. Step 1. Penalties. Find the difference between the two loads codes in each rows and columns. Step 2. Selection. Choose the rows or column with the highest penalty. Step 3. Allocation. Assign the maximum possible units to the cell with the lowest costs in the rows or column. Step 4. Repeat. Update supplies and demand, cross out satisfied lines, and recalculate penalties until finish. To finish one, we have all the allocation in the table. We multiply the assigned units and assigned unit by their corresponding transport costs and sum them up. For example, Vogel approximation methods. Difference act unit. Finish. Finish up the penalty. Following this process, we obtain a total transportation cost of 1,453,530. Thank you.
Cordial greeting. My name is Catalina Delgado León, a member of Group 170 for the deterministic methods course. Next, in will explain the development of the integer programming model for tag B. Unit 2. Regarding the result, the interpretation is as follows. To minimize total production cost of $4,777,700. The company must produce an optimum mix on 178 units of tip under day and 200 and on units of tip tone day. According to the model producing tip 3 dayum is no cost effective 3 equals 0 because the rosette constraint for cut polygons and Alexine are lady effective meet with the fits to produce tit solutes and sorted white sat fit the medium recovery requirements with achieve the each possible economically effective for the planners. Thank you.
Good night, estimados tutores, tutora y compañeros del curso de determinísticos de la UNAM. Mi nombre es Jacqueline Martínez Mena, estudiante de Ingeniería Industrial. El día de hoy vamos a realizar la exposición del punto 3 del ejercicio B de métodos de asignación. Voy a compartir pantalla para realizar la respectiva explicación. El día de hoy tenemos el ejercicio 3, métodos de asignación, letra B. En este momento les voy a explicar un poquito el ejercicio y ahí voy paso al final. En una compañía petrolera concursan 7 operarios para ser asignados a 6 diferentes máquinas, debiendo ser asignados cada máquina a un único operario. La habilidad de los operarios para operar las máquinas se encuentran en la tabla de asignación. La compañía petrolera debe encontrar la habilidad de total velocidad de asignación a los operarios de las máquinas. Como nos explican, hay 7 operarios para 6 máquinas. Entonces, para el operario número 7 nos toca salir una máquina ficticia, la cual la encontramos aquí, la rellenamos de 0 porque pues, no está puesta dentro del trabajo, del trabajo en equipo. Luego encontramos el valor máximo de tiempo en horas, perdón, de la habilidad que tienen en las máquinas, perdón, los operarios. Luego encontramos el valor menor que tienen los operarios. Hacemos la respectiva de encontrar los tipos de ceros para ver cuántos números de ceros, cuántos ceros nos dan, para según esto miramos a través de trazamos una línea donde mayor ceros encontremos. Esto nos da como resultado el ejercicio, buscando el cero con mayor valor. Lo hacemos comparación con esta tabla. Ahora sí, vamos a hablar de la habilidad que tiene, es 642. Bueno, vamos a hacer una pequeña explicación en inglés de los resultados dados en esta ocasión. Y disculparán el inglés, no soy muy buena, pero hacemos lo posible. Operate 1 is assigned to machine 1 with a skill of 109. Operator 2 is assigned to machine 5 with a skill of 106. Operator 3 must be assigned to machine 4 with a skill of 106. Operate 4 must assign to machine 6 with a skill of 105. Operate 5 must be assigned to machine 2 with a skill of 108. Operate 6 must be assigned to machine 3 with a skill of 108. Operate 7 must be assigned to my effective machine with a serious skill. In the oil company, the skill of the 7 operators would participate is 642. Thank you very much.